Super nice to be here. My name is Thorngren, and I am product leader for autonomous trucks. So I do, with my team, define and set up how our autonomous truck works. So my perspective is the ownership of the completeness of the system. So I'm working with brakes, working with packaging, working with wire harness, working with engines, the tutti of the whole solution. So my end target is a working autonomous truck, and I start with code. Just to get some background, I've been doing software for roughly 40 years, and my first start was actually here in Germany. That's why I speak some German. Starting off building web portals for a couple of years. And then I was part of that disruption. And then in 2001, the market on that side was disrupted. So I shifted into building smartphones. And then we got disrupted 2007. So the market was destroyed where I was working once again. So this was my second disruption. And then moving into trucks, I've been doing trucks for quite a while now. I just started, as I said, 2007. And that means I've been doing trucks for roughly 15 years out of the 40 years of my experience with software. So these days, it's fascinating. This is completely fascinating. If I compare, you've seen I've been disrupted three times already in my lifetime. If I compare those 3 times with what I'm seeing now happening in the transport business, I would say that the 3 other disruptions that I saw was nothing compared to what we are facing now in autonomous, in the trucking business. We are shifting into autonomous systems, obviously, but we're doing them electrified, and we're doing them connected, and we are digitalizing the whole process. So it's a 4 major shift in one big take. So that's really fascinating, and that's why I really think that I'm in the right spot at the right moment. Actually, again, because I was part of the other shifts as well. So the main focus we have when doing this from Agile or from a perspective of the product is to create a really fast build a product and get it measured and get the data and go into learning phase. So success is about doing this cycle extremely fast. So we have a clear connection with the product at all the time. So normally you would find me not wearing this suit. You would find me wearing a yellow suit, and you will find me wearing steel shoes in a truck. That's where I normally spend 60 to 70% of my time. The rest of the time I spend with customers or with the teams. So we are really product-centric, and my desk is next to the trucks. So I'm not sitting in office space, I'm sitting with the trucks. So if I look with my internet eyes on this, this part is where we shined as internet developers many years ago. I was, for example, building the first payment systems, at least in Sweden, around 94, 95, for banking. And I was also doing the first real estate systems in roughly the same time. At that time, I had at my keyboard complete control over the customer experience, all the different pieces of this process. I could tell every minute if we have a 404, error 404 problem. I knew that in minutes or seconds that I had made a mistake. So we were really good in internet business on the measure and learn side. That was something excellent. But if you're going to the automotive industry, the focus has always been on the actual build process. We are securing the build process. We're creating processes, A spice, D spice, A spice, whatever, to control the build. But the automotive industry is not specially focused on the measure and learn parts. This comes from being mechatronic companies, and in mechatronic companies, you have a complexity that I did not have as a developer some 30 years ago, building systems for selling real estate. So the trick we need to fix in automotive is to combine these things. We need to figure out how do we secure that we have the really good mechatronic build systems, because mechatronic systems are immensely complex to build. It's nothing you just invent in a few seconds or minutes. Brake systems takes, ZF, for example here, takes years and years to build, and they take many, many, many months to certify. Same with engines, same with ADAS system, same with autonomous driving systems. So we are living in a mechatronic world with high complexity of the build, but we're also building, need to have the speed of the internet industry. So the trick is virtualization. How do we virtualize? How do we use those tools so that we get an efficient flow of products? Because in the end, I'm seated in the truck. I'm not sitting in the virtualization. And I detect and I measure our progress in the truck, not somewhere else. But I need the virtualizations to get to the truck. So they are my tool to move fast. Talking about this thing, obviously, people is important. That's the cornerstone of everything here. And I just want to emphasize that whatever I say later on, this is still the cornerstone. But I will not focus on that, because my assumption is that if we do a couple of things, then culture and these things will come along. But if you don't have those in place, then the culture and those things will not come along. So I will focus on what does it take, what kind of cornerstones do we need to build the ultra-fast loops so that we give and empower the people to do their work. In the product increment, with my team of product owners, we make videos, we make shows, we make VR solutions that we present to the different organizations in Volvo, telling them this is what we think the customer needs. And then we open up a space. Please deliver in 2, 4, 6 weeks, whatever we decide. And then they come back with us with a solution. So they have the freedom to do what they need, but we have a clear vision on what we believe that the customer needs at that point. So to take you on this journey, I have 5 steps in this journey. The first is the focus on value. What is value? The second step is how do we control the product data flow with the value, carrying the value, and the feedback loop, measuring the value back. How do we virtualize that process so we could use a mechatronic system in a CD in a continuous development process? The fourth one is how do we then create an ecosystem so that our suppliers could be part of that and we could deliver together? And the fifth one, going back to people, how do we get knowledge, understanding, and how do we increase the way and improve the way we work? So those are the 5 points on this journey. First point, value creation. It's really, really important to understand value. And the thing is that I do not understand value. Because the only person or organization that could detect value in the product I'm providing is the customers. So there is no way, no shortcut I could take to get that understanding. So the only thing I could do, I could build a lot of value propositions. I could make this new brake system with these capabilities, or this cluster with these capabilities, or this AD system with these capabilities, but it's just a value proposition. I have to measure it, I have to give it to customers to really see what it's worth. And that's what we call a value proposition model. It's not a value model, it's a value proposition model. They are not the same. So I need to take my value propositions and then have a very clear mathematical way of measuring them. And the reason why it has to be mathematical is because we are digitalizing. So everything has to be measurable, and we need to get data constantly. So it can't be like opinion-based. It must be fact-based. This is, at least if it starts, hope it does. This is an insight in our value proposition model. So I'm just recording a screenshot from how it's organized. So you could see all different types of products we're offering, value proposition offerings. We have more than 4,500 in a single product baseline. So it's every description of every type of value we could have in a truck. And it's linked to all the different product logic. So I could say that the product logic of remote engine start is provided in that truck, in that truck, and that truck, but not that truck. And I could tell that the criteria is that we should have a start within this and this milliseconds, and there should never be failings in this value. So this is basically what the value proposition is setting up, and it makes that I have a clear picture of exactly what is value propositions. The trick is then to get my value propositions to the customer and then see if the customer agrees with our value propositions, because otherwise we need to change them. So this is just a model for keeping this in control. This is very, very, very important, because if you don't have a value proposition model, you don't really know your values. If you don't really know your values, what are you really doing then? Because this is where we earn the money. When we convert our value propositions to value, that's where the revenue is. All of this value proposition has test cases that could measure in the truck if this value exists or not. And we spent 15 years building these systems, and I spent a few hours, I can tell you, getting this in place. And we are roughly 110 persons dealing with how to set it up, instrumenting our products, and getting the analytics back, and creating all these structures. So for example, just an example, we have built all the pipelines that are shoving the data with DevOps, the Ansible structures, all those stuff. We are utilizing 80% of Volvo AB's complete computational power to do that. And here you see, for example, typically how a truck is equipped with Ethernet-based logging system that are measuring all the buses, and a central test system that is detecting if the customer value is there. Is the washer wiper really starting? Is the cluster really presenting? Is the AD system detecting target? Is the steering system really steering correctly? So this is the measuring system. So that's about value creation. Do not underestimate that part, because whatever you do, it must start in your value creation. Otherwise, you are mostly wasting your time. When we have understood the value creation and how we create value propositions, we need to be fast. So we need to have an automated way of pushing the deliveries through so that I get them into the truck. And typically, we have two main flows of data in automotive. We have a product data flow coming from us to the customer, and we have a feedback flow coming from customers to us building the truck. We are the R&D development organization, and we need data. What's working, what's not working, and we need to push out data constantly. This is our next proposition, this is our next proposition. So the product data flow is a mathematical definition of all parts of the truck. So it's pure maths. Nothing, I think that, I think this. Nothing, just maths. On equations, on software, on mechatronic systems, on mechanical structure, on pinning, everything maths. So, and the feedback flow is actually also based on getting data. Is the customer really using the Hill Start 8 system? He tells us he is, but he's not. Could detect that. Customers, we rely fairly little on what the customer opinions, because they don't really match what you see, how they're using the systems. So we focus on how the system is used, not what they tell us that they're using. It's interesting to have both, because then you could understand what kind of mismatch do you have. If the customer is telling us that they're using a system that are not using, there must be a misunderstanding someplace. Or if the customer pretends and says that something is not working that doesn't exist. I mean, it doesn't exist, so it's obviously not working. But get these things in line. Okay, digitalization for me in automotive is something very, very precise. It's not a fluffy word, it's a very precise thing. Digitalization is how well do we combine the product data flow coming, from the customer, from us to the customer, and get data back. The amount of steps that we could automate tells me the digitalization level. And it means really, I could measure digitalization in percentage. Because if I have a product data flow, let's say of 6.5 million elements, and I have a feedback flow, let's say of 1.2 million elements, and if I can combine all those automation points, meaning that I could automate the decision making. Super simple example. If I have a gearbox, which is steered in the product data, and the gearbox is supposed to get me this much improvement in fuel consumption. Then I'll need to measure the improvements in fuel consumption. And if the system we have is giving us data that we are reducing fuel efficiency, then we have an automated decision point, approve that system, giving that everything else is okay. So digitalization is about automating decision points. The ideal world in a completely digitalized company would be there would be no decisions. Everything would be automated. You would just say to the system, start building trucks, and then you would have trucks. It's a bit, we are not there in the upcoming years, but just to envision what digitalization really means. So we could look at the process and say, this process is 42.7% digitalized, that one is 72.3%. You follow? So this is not something fluffy, it's very, very precise what we mean. Cornerstone. So looking at Volvo, this is typically how this setup looks in Volvo. We have to the left, we have the product development organization, the R&D, and to the right, the sales and customer organization. And looking into this one, we could see how the customers order trucks, and then we build the trucks. And we have a different elements that the truck is built. And the orange points are the data collection points. So this is where we collect the data that we need to feed over to the product development flow. I would say today, one of our main weaknesses is that this feedback flow is not well working. That's something we need to improve. That's not due to that we are failing technically. It's due to legislation and a lot of rules making and marketing blocks and stuff like that that is not technical, actually. So going into the product data flow, we have basically 4 major elements on how to build a truck. We need some requirements. We need some test objects that's equal to trucks or similar. And we need tests. This goes back to the value model I talked about before. We have a value model, and the test tells us when the value model is fulfilled. And then we need 9 different types of data that we need to modify. And every type of data is then broken down into subcategories of data. So it's super specific what the truck is. It's the combination of those 9 data elements and their subcategories. That's a truck. So I bring that truck in, and then we iterate daily this cycle. So I start in the morning with the deliveries I got 8:30, and then I tell the team 16:45 what kind of advancement we've made, and I have a constant flow of deliveries all through the day with data. And everything is pushed through our pipelines in the DevOps systems that we have. And these are the major 9 elements of the data. Just looking at data, we also measure every data type, and we do that from 4 perspectives. We measure the data from velocity perspective, how many elements of the pinning or elements of the wiring harness or of the parameters of the code do we have in the current build flow that tells us, do we need to scale the build system? Do we need to improve here? Very important is efficiency. If the wiring harness team or the pinning team spends time doing their work like 3 months in advance, and we place that on a server, and we wait 3 months to the software, what is that? If the pinning takes place 3 months before and the software is made 3 months later, what is it? It's waste. Shouldn't be done. Because we should have coordinated and secured that we did not spend time on the wiring harness when it wasn't needed. So it's extremely important to constantly monitor your efficiency of your data elements. So we could tell the organization, stop doing that. That's not that vital. You need to do this instead. Then we have the time of the build times. And then we have the load telling us how many elements could we currently carry in the backend systems. So that's the flow. So the flow should support the creation. Now we need to virtualize things because we are not building web pages, we're building mechatronic systems. So doing that, we need a number of different solutions. This is typically one of our solutions. Lower right is the engine VR system, and left is the packaging system. So the pipelines are also filling and providing the VR systems with data so that the teams doing non-software still could be part of the DevOps process. and those things are automated. We also have actually, which is quite fun, drivable virtual trucks, which we present at some conferences actually. It's a bit too far to bring to Berlin, but otherwise it's a super fun thing where you could experience our product yourself. You drive them yourself. Basically, to do this, we have 6 major types of test systems. We have pure virtual software in loop systems. We have mixed, where we bring in networks. That's number 2, the black ones to the left. And then we have actually a simple version of the drivable truck. It's just the seat and the steering wheel on the picture. And then we have huge hardware rigs that we build ourselves. And then we go into the truck where parts of the system could be virtualized. We could have virtualized ADAS system or virtualized engines. But the rest of the truck is correct. It's a real truck. And then I live in the real truck. That's where I live. Because I need other ones, but they are not just tools. Just tools to get me to the rightmost place. And some ideas on the amount of tests that could be performed during an hour. And you see we scale it almost indefinitely when it comes to the leftmost side. So, next thing. We've done the virtualization, we've done the pipeline, and we've done the value creation. Then we need to move into the ecosystem. How do we support our suppliers? How do we support our employees and create the ecosystem? Obviously, we are publishing a number of public Git repositories that are available to you guys already today. You need some contracts to make this work. We are also offering some suppliers a virtual truck, so they get the virtualization. And if they have other contracts, they could even be connected to our build chain. So when they build something like a brake system or something, it's immediately connected to our engine system or our cluster system, so we could immediately get that feedback going. And we have an internal ecosystem as well for developer. Something that is so super important is to create this feeling of empowerment and feeling of having access to all these technologies. So I don't believe in placing tabletop tennis things all over the place, but I'm really, really happy when people take down our rig development toolkits and start developing themselves. They take down source code, because we have most of our source code under control, almost all, so they could themselves start developing. Or if they go to the cutting machine for steel axles and cut axles. So be creative, but take them into the context of what we're doing. Tabletop tennis is super fun, but do it someplace else. It's not really that creates agility. It's interacting with all these fascinating technologies we have in a truck. And a truck has mechatronics, chemical systems, software system, pneumatic system, you name it, it's there. So there is unlimited domains of exploring new stuff. So, last but not least, my favorite topic actually, it's about skills and knowledge. Because when I started this, I said that this is about people. This is about people. And it's good that we have the things that we presented earlier today. We talked about that we need to empower people. They need to have the right culture. Yeah, don't mind that. But my strong belief is that it's not something you could have a meeting about and everybody could agree, let's get open and let's get trust. That's not how it works. The foundation is skills and knowledge. So when my management asks me, what's your major 3 hurdles of making this journey? I say, I have 3 problems. I have skills and competences, and I have skills and competences, and I have skills and competences. If you solve those 3 things for me, that's when we get things moving. Because do you think that this is a complex system? It is a complex system. It's super complex. So the only way to deal with that is to cut it in smaller pieces, virtualize them, and create simplifications, and then train people so they could take on all this complexity. Because it's immensely complex with a mechatronic system like a truck. And we are now moving into a complete transport solution, at least when we're doing the autonomous. It's not about providing a truck, it's about providing a complete transport solution. including loading, unloading, including cargo management, including all those steps. And then doing it electrified on top of that. So skills and knowledge is really, really important. And once again, please get close to the product when you do this. Don't mind the tabletop, but it's very, very important that you always have the closeness to the product. You should know the brake system. You should know the cluster. You should be aware of the pressure management system or the pneumatic system. You should know that. You should know the backend system. You should know about cloud services and those things. So it's sort of on-the-job training that is needed. In addition to what I showed before, we are launching 4 different types of learnings. So we rely heavily on video recordings. So we have, when we start the product launches, there is a video where we, as the product team, show the organization, this is what we intend to launch. Or we have a VR presentation or something that really tells the organization, this is what we will achieve in 2 weeks, 4 weeks, 6 weeks. So there's a clear vision and it should be very, very understandable. That's why we use video more than documents, actually. So all in all, I think these are the 5 major pillars that actually, I think, we have proven to be fairly successful with these things. We are fairly fast today to do these things. And I hope we could continue. There is always steps and openings for improvements. The only thing you learn when you learn stuff is that you don't really know. That's the whole thing of learning, because then you understand where your limitations on learning are. So we have tremendously much to learn, but we have come a far way as well. And I think that is so important, because then we build self-confidence in the organization when we know that we can deliver, when we know that we can see these things done. We could put up a vision and have it done. So as an example, final example, I have a small film with my colleagues where we are telling the organization about a launch. So you could just listen in when they talk, my colleagues. And as you might know, Volvo is not only Volvo. We are building Renault trucks, we are building UD trucks, we are building Asia trucks, we are building Mack trucks, and we're building Volvo North America. And our product line builds them all. So we just have different test objects. So this is my colleagues now.
This Volvo FH 750 got new software just a few minutes ago, bringing customer value in the form of improved slow cruise.
This is the new full electric Volvo FH. It also received new software just a few minutes ago, bringing the customer value of improved slow cruise.
Do you think this is a Volvo FM? No, this is actually a North American Volvo new. This also got the new software just a few minutes ago with improved slow cruise.
The software is created and tested continuously, improving customer value every day.
Every day we update all of our products with the latest software to provide fast feedback. And then every 2 weeks all of our products get a release candidate that go through more rigorous testing.
This is enabled by automation and a high degree of digitalization, but most importantly through cooperation between people across many different organizations delivering to our trucks.
All of these trucks receive software value every day.
So that was the end, or the start.
So we've got time for, I would say, 2 questions. Yeah, I'm running.
Thank you. Great presentation. Can you tell us a little bit more about these value models? What is inside these models? The logic, or is this the kind of benefit hypothesis, and how they how they deliver value to the end customer.
Yeah. Okay. I'll take a very safe area because it's not NDAs that I'm touching. I'll talk about washer wiper. So washer wiper could be done with a rain sensor, without the rain sensor. Agree? It could be done with a target of removing moist or with a target of reducing dust. And we have then 7 different brands. So now we have 7 combinations with 4 different outcomes. So I just multiply 4 by 7, and then I have the first basic value model. You follow me? Am I able to remove dust in a Renault? Am I able to remove rain in a Renault? Am I able to remove, and so on, so on, so on. And then we look at the market and see what's good, what's not working, what do we need to improve. Then you get another inclusion. For example, we need an autonomous solution here. Do we add a new one? Because the autonomous solution needs air instead, sometimes, to remove. So you basically, block by block, piece by piece, create your value models where you describe a certain specific benefit to the customer. And the real customer benefit is for a driver to see out in rain and dust, and for autonomous system to be able to detect targets. Makes sense? It's a bit more complex when it comes to autonomous trucks.
Okay, one more short question.
Can you give us one example of the data-driven decisions? First of all, I liked very much when you said that you focus on how the customer uses the system instead of what the customer actually says. But then I have seen the data-driven decisions, and there was like feedback data and product data. So I was wondering, okay, what kind of feedback is this? Is this feedback customer? Because before the statement I made before, it's a kind of contradictory to the data-driven decision. Maybe you can just explain the data-driven.
Super simple example again, not breaking NDAs. A truck must consume as little current as possible, preferably 0.3 amps per hour. That's in order to make it start again. And people like trucks that start; they're really fond of that. So we need to pressure down the measurement. We place a measure sensor on the battery, detecting the current that is consumed. And with the new solution, obviously, when it's driving, we measure constantly what current consumption it has. And if we have improved, it's a better delivery. You follow? So everything in the truck is mathematics. No, like I feel that and feel this. Don't care about that. Just hard facts.